All right, today we're going to be talking about probability models. So the first thing we're going to be talking about is this idea of a fair decision. So in our example here, we're going to look at an example and determine if that is a fair decision or not a fair decision. So our example is a class of 25 students wants to choose 3 students at random to bring food for a class party. Any set of 3 students should have an equal chance of being chosen. Which of the following strategies will result in a fair decision? The first one, A, the students line up alphabetically, and each one in succession flips a fair coin. The first 3 students to flip heads brings the food. Now, is this a fair decision? What's the problem with this model? Well, first of all, the first person that flips it has a 50% chance of having to bring food or not bring food. So the likelihood is that someone at the beginning of the alphabet has a higher probability to have to bring food than someone at the end. So somebody that has a last name of Z or W probably isn't going to have to bring food, where somebody with a last name of A or B has a higher likelihood. So this is not a fair decision. Each student draws a card from a well-shuffled deck of cards. The teacher shuffles a second deck of cards, spreads them out, and draws cards one by one until he matches the cards of 3 students. Now, is this a fair opportunity? Does each person have the same likelihood of being selected? Does a person with the last name A have the same likelihood of being drawn as someone with the last name Z? The answer is yes, this is a fair decision. This would be a fair representation in how to manipulate and get those. The next one we're going to look at, the next probability model, is using random numbers. So here I have a string of random numbers that were generated. And we're going to kind of look at how do I use random numbers to determine as a probability model. So our example here is a coach wants to select 3 of her 15 basketball players at random to lead warm-ups before practice each week. The coach assigned each player a number from 0, 1 to 15. How can the coach use the random number table to fairly choose the 3 players? So remember, we have players here, 0, 1, 0, 2, all the way down to 13, 14, 15. We want to make sure that we understand we're using 0, 1 because it's a 2-digit number. The reason we have to use 2-digit numbers is once we get up to 10, the rest of the team all has 2 digits. So what we're going to do is we're going to break this random number up into 2-digit pieces. So the first one, we look at the first 2 digits here. 87. Well, 87 is out of our range here. We're only looking for numbers 0, 1 through 15, so it doesn't work. I go to the next 2 digits, 49. 49 is once again out of our zone, so we go to the next one, which is 43. Here I'm using 2 of them, doesn't work. 77 doesn't work. My first one that works here is 07. So player 07 is going to be our first person to lead warm-ups. I go to the next 2. 2-0, too big. 5-2, too big. 5-9, too big. 5-7, too big. Now we come to 04. There's my second player. And I keep going through these random numbers until I get to one that works at 12. There's our random number generator. We can use that to find the players. We can use it as a probability model. All right. So the last example what we're going to talk about is kind of getting an average. What would your expected value be by using a probability model? All right. So a probability model is something that you can actively use to determine, like a die, a coin, something like a spinner. So what we're going to look at is we're going to look at example 3, and this will be our last one. A restaurant gives away 4 different toys in their kids' meal. Each meal contains exactly 1 toy, and the toys are equally and randomly distributed. about how many kids' meals would a parent expect to have to buy to get all 4 toys. So on this one, what we're going to do is we're going to set up a spinner. So we might have this spinner here, and we might have toy 1, toy 2, toy 3, and toy 4. And we have this spinner here, and we're going to spin it. Now, we're not physically going to spin it. We're going to just say that we've spun it. So here we have toy 1, toy 2, toy 3, toy 4. And let's say as I'm spinning this, I end up, the first time I spin this spinner, I end up with toy 1. Okay? The next time I spin it, I get toy 4. And I keep spinning it, and I get, toy 2, toy 1, toy 2, toy 4, toy 2, and then finally, I get toy 3. So my frequency here is 2, 3, 1, 2. Right? If I add these all up, I end up here with that my result is I got it in 8 tries. Now that doesn't necessarily mean that every time I'm going to get it in 8. I could, in theory, get it in 4 times. Right? I might get toy 1 first, and then toy 2, toy 3, toy 4, because they all have an equal likelihood. And so what I would do is I would repeat this experiment over and over and over again and add up the totals for experiment 1, experiment 2, experiment 3. So if I come in here, and let's say I have experiment 1, and it took me 8 times. Experiment 2 was 7, 3 was 9, 4 was 12, 5 was 6, and then 15.
You can't see the 4 on the phone.
Can't see the 4?
There you go.
All right. So, and really 6 experiments probably isn't enough to determine my expected value. I'd probably want to have considerable more, but you kind of get the idea. So what I would do is add these up. 8 plus 7 plus 9 plus 12 plus 6 plus 15. And I'm going to divide that by how many experiments there were, which is 6. So I would go in, I'd find my average there. So that's 8 plus 7 plus 9 plus 12 plus 6 plus 15. And I get that I would expect in 9.5 meals to get that. So probably can't have a half a meal, so I'd have to round that up to an average of 10 meals. That's probability models. Hope you understand it.